All right, quick show of hands. When I say artificial intelligence, how many of you immediately think of sentient robots like R2-D2, Data from Star Trek, and HAL 9000? Okay? This is what we refer to as artificial general intelligence, or general AI. It's a type of futuristic artificial intelligence designed to solve a very general set of problems that we encounter in our day-to-day lives. And how many of you think of modern data-driven AI? Things like IBM's Watson, Amazon Alexa, and Google's self-driving car, okay? This is what we refer to as artificial narrow intelligence, or narrow AI. It's a type of modern AI that's designed to solve a very narrow set of specific problems. And just for fun, how many of you all think of crazy killer robots hell-bent on destroying all of the humans on Earth? Okay, this is what we call crazy killer robot AI, for obvious reasons, because they're crazy and want to kill all the humans. Now, I personally think each of these three topics is an equally interesting topic to talk on about artificial intelligence, especially the crazy killer robots. But today, we're going to be focusing this presentation on artificial narrow intelligence, the type of AI that we have today, the type of AI that solves a very narrow set of specific problems, but is likely going to change our world in more ways than we could possibly imagine in the next few decades. Whether you realize it or not, our world is going through a significant transition as we speak. We're entering the era of artificial intelligence and machine learning, a future where machines are going to be doing many of the jobs that human beings are currently doing. As a result, the software industry is also going through a major transition as well, or preparing to go through this transition. Now, in the past, as software developers, in order to solve a problem with a computer, we'd have to write a program and teach that computer, tell it how to solve that problem step by step. We call this explicit programming. It involves a lot of if-then statements, a lot of for loops, and a lot of logical operations. In the future, however, machines are going to be solving these problems on their own. We just need to provide the data. And now, this is a radically different way of working with a computer than we're used to as software developers and IT professionals. While there's a growing demand for individuals with the skills necessary to teach machines with this new AI technology, there's currently a shortage of individuals capable of teaching machines in this new way. As a result, those with the skills necessary to teach machines with AI are commanding significantly higher salaries in the IT industry, and there doesn't seem to be any end to this trend in sight. The purpose of this presentation is to introduce you to modern data-driven artificial intelligence, a new way of teaching a computer how to solve a problem without explicitly programming it to do so. We'll do this by answering the following three questions. What is data-driven AI? Why is it important all of a sudden? And how will it affect you, your career, and our future? First, what is artificial intelligence? Artificial intelligence is a field of computer science or subfield of computer science that attempts to create machines that act rationally in response to their environment. Examples of AI include things like computers that can play chess, Google's predictive search algorithm, non-player characters in video games, and navigation software on your smartphone. Essentially, any computer algorithm that can replicate some aspect of human intelligence or natural intelligence is a form of artificial intelligence. Now, AI has been around for quite some time. In fact, the field of artificial intelligence dates all the way back to the 1950s. In the past, we had several machines that were capable of making rational decisions. However, they had to be explicitly programmed to do so, and they could only operate successfully in very constrained or narrow sets of environments. They were very fragile. They would stop operating if given novel conditions, things they weren't used to expecting. There was a lot of hype about the potential of artificial intelligence way back in the day. Experts were predicting that machines would soon replace human labor in almost every category of work. But it never happened. And by the end of the 1990s, machines couldn't even solve basic toy problems that even a toddler could solve. The inflated hype about the potential of artificial intelligence and subsequent disillusionment when none of this stuff ever came true led to what we now refer to as the AI winter or AI winters, depending upon who you talk to. A period of time between the late 1970s into the early 2000s where funding and interest for artificial intelligence and machine learning had almost dried up entirely. However, by the mid-2000s, the AI winter has ended and things are really starting to warm up again. In fact, they're actually getting very hot right now. So let's take a look at a few examples of modern AI, just so we have kind of an idea of what the landscape looks like. So first example here is the Tipsy Robot. This is essentially an autonomous bartender in Las Vegas. We've been there several times. We actually really enjoy its drinks. So you place your drink order using a tablet at your table, like the tablet's just sitting there. You can make either a predefined drinks from a list of drinks or a custom drink by selecting the ingredients. Then the robot essentially goes off and makes your drink, It charges you through the tablet. You just swipe your credit card. In fact, there's only one human being in the entire bar, and that's a manager essentially overseeing the operations and just making the environment social. The robots are doing all of the work. And second, I was in Hamburg, Germany about a year ago, and we're sitting at a dinner table, and all of a sudden one of these little things just goes right by my leg, and I'm like, what on earth is that? And I just had to learn more. So this is an fully autonomous delivery robot by Hermses and Starship that's been successfully delivering packages in Hamburg, Germany since 2017. They've now expanded it to other major cities in Europe, and it works really well. You essentially put the package in the robot takes it to its destination, the person unlocks the robot with their smartphone, gets their package, and problem solved. The only real issue I've heard that they run into this is in Hamburg, Germany, there's a lot of drunk guys leaving bars, and they like to kick these things over when they see them. But other than that, highly successful. And finally, we have Google's Voice Assistant. Now, many of you have Google's Voice Assistant on your smartphone. It's an Android, essentially, application that they've been using for quite some time. However, Google's constantly experimenting with the AI capabilities of this software, and one of the new features they're experimenting with is an agent that can make appointments on your behalf. It works like this. You say, Google, make me a haircut appointment on Tuesday anytime between 10 and 2. And it says, no problem. I'll make you an appointment and update you soon. Then the Google Voice Assistant agent goes off and makes a phone call to your hair salon and schedules the appointment. Now, when you listen to this video, keep in mind that the person on the other end has no idea that they're talking to a machine.
So how can I help you?
Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second. Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
And now I need to point out that although this is a very impressive demo, it's actually quite deceptive. While these new data-driven AI technologies are extremely good at pattern recognition and generating patterns like the sound of a human voice, they're not very good at reasoning. And so there's still a big gap here in the technology. So although it looks extremely impressive, keep in mind that there's a lot of magic happening behind the scenes. Why has artificial intelligence become so important all of a sudden? What caused the AI winter to end, and why should we think now is going to be any different than the last time? To understand why, we need to look at 3 trends that are really driving modern data-driven AI, the whole movement. We have machine learning, deep learning, and reinforcement learning. These 3 trends are both making data-driven AI possible and increasing the value that modern AI can provide. First, we have machine learning. Machine learning is a subfield of artificial intelligence based on statistics. It involves machines learning how to solve a problem without being explicitly programmed to do so. It does this by detecting statistical patterns and correlations in data. Essentially, with machine learning, we use existing data and a training algorithm to learn a model of the data so that we can feed new data into that model that it's never seen before, and it will make a prediction about this new data it's never seen. A machine learning model is essentially a function. Xander and I talked about functions yesterday. It's essentially a mapping from an input to an output. In this case, it's taking data as its input, and it's producing a prediction as its output. For example, imagine we want to create a function that determines whether a photo contains an image of a cat or not. First, we'd need to create a data set of images that contain cats and images without cats. We'd have a human sit and hand label each of these images saying this one's a cat and this one's not a cat, so that we'd know which photos contain the cat and which ones contain something else. Next, we would apply a machine learning training algorithm to this data set labeled with cats and not cats to determine, or so that it can essentially learn what catness is. What is it about the photos that contain a cat that corresponds to them actually being a cat? They have pointy ears, they've got whiskers, things in the image that correspond with it actually containing a cat. Next, the training algorithm produces a model. It's essentially a function that we can feed data into to predict whether that image, a new image, contains a cat or not. And so if we've done everything correctly, we can feed a new image into this function, into this model, and it will tell us whether it contains a cat or not, more specifically, the statistical likelihood that that image contains a cat based on every other photo it's seen with cats and not cats. And now, while this is a vastly oversimplified explanation of machine learning, it essentially captures the essence of what it is that we're attempting to accomplish. We feed data in, we build a model, and then we use that model to make predictions about new data it's never seen before. There are a lot of things that we can do with modern machine learning. Some examples of tasks that modern machine learning can do are things like classification, where we make a decision or a prediction based on 2 or more categories or outcomes. For example, deciding whether to accept or reject a loan based on a customer's financial history. Regression, where we attempt to predict a numeric outcome based on 1 or more input variables. For example, trying to predict how much a house will sell for based on the sale price of houses that are similar to it based on all the features contained in the house. We can then predict how much a new house that we've never seen before will likely sell for. We can also do things like clustering, where we group objects together based on similarities in their data. For example, grouping customers into marketing segments based upon their demographics. And anomaly detection, where we find things that are different in the data, things that are outliers, essentially. For example, detecting an unusual spike in the negative comments about a new product that's being released, or doing log file analysis and detecting that we have some kind of intrusion in the system. So machine learning allows us to do some pretty interesting things. For example, we can figure out what kinds of products are sold frequently together. For example, we learn interesting stuff, like beer and diapers are actually commonly sold together. And so it's been rumored that some major US retailers actually started putting the beer next to the diapers in order to increase impulse purchases. And this is essentially the pre-Amazon era recommendation system. Rather than, oh, you'll probably like this product, we just put the products next to one another so you'd be, oh yeah, I'm buying diapers. I should probably get some beer. Machine learning can also do more complex predictions as well. For example, purchasing certain products together, like mineral supplements, extra large bags of cotton balls, and large amounts of unscented lotion are strong statistical indicators that you're likely to be pregnant. In fact, one major US retailer can actually use your product purchases to determine your due date within a relatively narrow window of time. They're actually pretty good at doing this now. And machine learning can even make accurate predictions about hurricanes. Well, not the hurricanes themselves, but what we can accurately predict with machine learning is that sales of strawberry Pop-Tarts, those delicious breakfast toaster pastries, will increase 7-fold in the days leading up to a hurricane. In fact, a major US retailer now anticipatorily ships these Pop-Tarts, delicious survival foods, if you will, right in the path of a hurricane soon before it makes landfall in preparation. Otherwise, they're completely gone off the shelves. So all of these super interesting discoveries and predictions are made possible now with large data sets and machine learning. This is just the beginning of the super cool and sometimes really creepy stuff that we're going to be able to do here in the very near future. This is just the tip of the iceberg for it. And if you're interested, I'd be more than happy to discuss all the super creepy stuff that I know is either out there now or is coming out soon during the Q&A. So machine learning gives data-driven AI the ability to identify patterns, to make decisions, and to predict outcomes using data alone. Now, this is quite powerful, but it does have a few limitations. And to work around some of these limitations, we've invented a new technology called deep learning. So deep learning is a new type of data-driven AI that essentially stacks multiple layers of machine learning, one on top of the other, in order to learn more complex functions. Essentially, by more complex functions, we mean map more complex input to more complex output. So a deep neural network is essentially a neural network that has one or more hidden layer, or more than one hidden layer. And adding a new hidden layer allows the network to model progressively more complex functions. For example, if we wanted to build a deep neural network to detect human faces, essentially we would feed a bunch of faces into the input layer of the network. And we do that to teach it what different faces look like. The first layer of the neural network would learn to detect geometric primitives, things like vertical lines, horizontal lines, diagonal lines, etc. The middle or second layer of the network would learn to detect more complex facial features, things like eyes, nose, and mouth, compositions of these geometric primitives when you put them all together. We get further up in the network, and the third layer or so would learn to detect entire patterns for whole faces. And when we get to the output layer of this network, essentially we're able to produce the most abstract representation of that function, which is essentially the name of the person being recognized. Each subsequent layer learns to extract more complex features from the previous layer. So the abstractness of the data increases the further up the network that we go. In addition, we can also flip these networks around and take abstract inputs to produce complex outputs, a technique that we use in something called a generative adversarial network, which we'll show here in a little bit. It's the technology behind deep fakes. How many of you have heard of a deep fake? Okay, so about half the room. Excellent. So deep learning takes us beyond using simple tabular data and producing simple numerical and categorical predictions as output. It allows us to use complex data as input and map that data to complex outputs. This includes text, images, audio, video, and more. This allows us to do some pretty interesting things. For example, we can now do real-time object detection, video segmentation, and motion detection all in real time. In addition, we can also use it to generate synthetic output as well. In fact, if you look at these celebrities, they all look like people you know, but not a single one of these is a real human person. These are all synthetically generated celebrities from a database of 200,000 images of real celebrities. Not a single person is a real person. Some of you are like, I don't believe it. Well, let's see. So this is the algorithm as it's progressively learning to generate more complex and higher resolution celebrities. It starts out being very crude in its approximation for what a celebrity's face looks like based on its data set. But as you see, each day that it's been training, it gets progressively better at generating more complex and higher resolution images of celebrities, to the point where these faces are almost indistinguishable from, a real photo of a person. We have to use pretty intense mathematical processes to determine whether it's actually a real photo or not. And check this out. The following 4 videos were produced entirely using a lip-syncing deep learning algorithm trained on hours of videos of former President Barack Obama. All 4 of these videos are completely synthetic as well, and I apologize, the volume is going to be quiet.
To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs.
So we can now take a person's face and make them say something that they've never said before. And you can imagine how concerning this could be if people use this technology for nefarious purposes. But more importantly, if the general public is not ready for this. And right now, the majority of people in the United States or around the world have no idea that this technology is even possible, let alone what kind of things could be done with it if someone chose to do so. And speaking of celebrities, I'm sure you guys all remember this classic scene from the 1984 sci-fi film Terminator starring Sylvester Stallone. It was Sylvester Stallone, right? It had to be Sylvester Stallone. I mean, clearly, this is Sylvester Stallone, the movie Terminator, right? So those of you that remember this movie know that no, it was actually Arnold Schwarzenegger. But using another technology called a deep fake, we can swap an actor's face in and out of a scene, once again getting someone to do something they've never done and without that person's consent. So I would like to tell you that all anyone has ever done with this technology so far is swap every actor and actress's face with Nicolas Cage. Unfortunately, that is not true. Currently, this technology is being used for some pretty scary things. We now have the ability to digitally remove people's clothing from photographs without their consent and to swap their faces into pornographic videos. And this is creating a whole new set of legal and ethical challenges that we've never had to deal with this before. And we're currently not prepared. Our legal system isn't prepared to deal with this kind of bullying or exploitation. And it's coming fast. Like, these are issues people are dealing with right now, but we have no system in place to protect them for it yet. So deep learning increases the power of data-driven AI by allowing us to perform machine learning on a much wider array of data types. And now this technology is really powerful, but it's still not as powerful as the final technique we're going to talk about, something that's up and coming right now, something called deep reinforcement learning. All right, so with reinforcement learning, we essentially have an agent that's interacting with an environment in order to achieve a goal of some kind. You can think of the agent as either like a robot or a vehicle, like a self-driving car. The agent is trying to achieve a multi-step goal within this environment. For example, trying to drive you from your home to your office while obeying all of the laws and getting you there as safely and as quickly as possible, while not hurting anyone else, I guess. The environment has state which the agent can observe. This includes things like the car's location, the conditions of the road, other vehicle locations, or anything that the agent sees, hears, feels, or senses via any sensor or means. So like LiDAR, radar, or you name it. The agent has actions that it can take which modify the state of the environment. For example, the car can move forward, it can move backwards, it can turn left, or it can turn right. All of these actions change the car's position on the road relative to all other obstacles and relative to the environment itself. Finally, the agent receives reward signals. We have to code these reward signals in, or essentially designate what we're going to use as the reward signal. This could be like giving the agent a point for each meter or foot that the car drives closer to its destination, while obeying all traffic laws and avoiding obstacles. Or we could subtract points for every time it drives too fast, or drives too slow, or goes off course, or any of those things. So we have to give it feedback as to whether it's doing a good job or not. The objective is for the agent to learn how to interact with the environment, all of the state of the environment, in such a way that it maximizes its reward score. In recent years, we've combined the deep learning technology we just talked about with reinforcement learning, which we just talked about now, to create deep reinforcement learning. And this has led to some pretty amazing breakthroughs in just the last couple years in data-driven AI. For example, we've taught deep reinforcement learning agents how to play basic 8-bit video games. For example, Atari's Breakout. In this case, the agent is the paddle, the state of the environment is essentially the pixels on the screen, the environment itself is the breakout game, the actions are left, right, or stay put, that's all it can do. The reward is essentially the score. We just OCR the text right up there and feed the score in 1 point at a time to the agent. And the goal is essentially to maximize the score. We haven't written a single line of code telling the agent anything about the game or the rules or the physics. We just feed it the data and tell it, here's your score, maximize it. So when it starts out, it's essentially completely random. It's just going to move around randomly, but every now and then the ball is going to bounce off of the paddle, and when that happens, it's going to score a point. It starts getting feedback as to, oh, hey, if I move the paddle and the paddle's next to this little block, then I get a point. So by about 100 games, it's pretty clumsy, but it's beginning to learn the physics of the game. By 200 examples, it's learned how to keep the ball in motion. It essentially understands the physics of the game. I put the paddle under the ball will bounce, and it will go up, and I score points. By 400 iterations, it's essentially learned to play the game at roughly average to expert level. By 600 iterations, it learns a strategy called tunneling. This is what the experts do when they play Breakout. They essentially try hitting the ball up along the side in order to build a little tunnel, and then get the ball up to the top. And once it's up in the top, the ball's just going to keep bouncing around there. That maximizes your score and minimizes the likelihood of the ball coming back down and you miss it. So this agent has not been programmed in any way, shape, or form. All the code there does is essentially set up the environment. It has learned a model of this game and learned the physics of playing the game all on its own. And this is, in a matter of hours, they can train these models now for a simple game like this. But that's just the beginning. So recently, we've been using deep reinforcement learning algorithms to teach artificial bodies how to walk. Once again, we have not programmed anything about the physics of movement into this agent. We just start it standing upright and just let it control its limbs and see how far forward it gets. Its points are how far it's moved forward. And so over time, it's essentially learned how to walk on its own. Obviously, it looks a bit weird in its walking, but it learned it on its own. And once you can get a virtual body to walk in a computer simulation, you're one step closer to getting an actual robot to walk in the real world. And I have to point out, this is really early on in the training examples because it's funnier to watch the robot flare around and stuff like that. But it's gotten so good that you can throw a boulder at it and it just kind of sways a little bit and just keeps walking. And now some of you might think, well, this is just a computer simulation. Like walking in the real world's tough. I do it every day, I know. Well, take a look at this. So not only can robots walk, they can currently jog. And now this involves a lot of traditional control mechanisms in addition to techniques like the deep reinforcement learning. So I can't say that they're doing this all with the technique I just showed before. But not only that, they can do this now too. Yeah. So in terms of things machines can now do that I can't, that's another one. So, but it's not all just fun and games. Like while reinforcement learning is currently being used to play video games, that's just kind of the test lab for it. Like this stuff is going to be moving out into the business world in the very near future. In fact, I'm starting to see the first business applications of deep reinforcement learning entering the software business space right now. Like this year is the first time I've seen something released. So in the very near future, we could see this combination of technologies doing everything from simple jobs like flipping a burger at a fast food restaurant to more complex like financial portfolio management. That all could be automated in just a few years. So reinforcement allows data-driven AI to solve complex problems on their own without the help of human beings. And this is really powerful stuff, and it's getting more powerful every year. So where are we currently at in terms of modern data-driven AI? What things can we currently do today? Well, these new trends are essentially leading to machines that are better than human beings at a variety of tasks. And we'll look at a couple of these tasks right now. For example, machines are now better than human beings at many visual tasks, including object recognition, object detection, gender classification, age regression, determining how old someone is, and emotion detection. Machines are actually better at detecting emotions than humans are now. Communication tasks like speech recognition, language translation, and even lip reading. We can actually read people's lips through windows with machines now if we want, like in automobiles and noisy environments. And various medical tasks such as diagnosing diseases, recommending prescriptions, and tailoring treatment plans to each individual patient based on their genetic data. It's something that a human doctor just couldn't do. There's too much data in someone's genome in order to parse all of this out. But these machine learning algorithms are able to do this now. And other tasks that I didn't include today, things like creative tasks. Machines are now better or can generate music that is indistinguishable to the average human from an actual human composer. So data-driven AI is getting better and better at these tasks, new tasks every day. However, there are certain tasks that it still struggles with. Some things like trying to decide whether an image contains a picture of a mop or a picture of a dog. And now this might make sense because some dogs look like mops and some mops look like dogs. But it's not just dogs and mops that these algorithms confuse. They also get confused by other categories of things like beagles and bagels and chihuahuas and muffins. But now if you're smart, you're probably thinking, well, we'll just tune all of the dog detection algorithms to only detect dogs. Problem solved, right? Yes, you can do that. And this is what you get. This is a deep learning algorithm that was trained to only see dogs. So the algorithm essentially is hallucinating dogs as it's walking through the supermarket. Like, that's just the trippiest thing ever. Yeah, what times we live in. All right, so how will this artificial intelligence stuff affect you, your career, and our future? We're going to take a look at a few examples of how data-driven AI will likely change our world in just the next decade or so. For example, in the near future, we're going to have self-driving vehicles, which will eventually replace all human drivers, most likely in automobiles, semis, boats, and eventually airplanes too. We'll have general-purpose robots that will be able to perform manual labor without being explicitly programmed to do so. You will show the robot how to complete the task just by grabbing its arm, saying, pick this up, put it here. We already have that technology now, but it's rapidly evolving. Smart buildings that will optimize energy efficiency and anticipate the needs of their occupants. I've worked on several of these projects myself. And eventually we'll have smart cities that will optimize municipal resources, things like electricity, water, waste, and traffic, without human intervention. The cities will essentially be able to manage these things themselves. We'll embed artificial intelligence in pretty much every aspect of our environment. It's likely that AI will be as ubiquitous in our society as electricity is today. And think of how fundamentally electricity changed our society. Same thing's going to be happening with artificial intelligence. It's essentially just going to be woven into the fabric of our society. Computers will kind of just disappear. It'll just be AI everywhere. Now, this is going to have a significant impact on our economy and capitalism as we know it. Unfortunately, it looks like this is going to lead to significantly more nonlinear economies. Those that have these smart machines and the ability to leverage them productively are probably going to have a lot more power, and those without these smart machines are likely going to have significantly less, unless we do something to regulate this. In addition, data will likely become one of the most valuable resources in our information society. Those that have the most data and the ability to enable AI with this data are going to wield tremendous power in our information economy. We'll also have an enormous impact on our labor economy. AI will eventually replace all human labor in certain classes of labor, or certain categories of labor. Given the economics driving this, it's much less if a given job will be replaced by AI. It's more a matter of when, how long will it take, or what technology will be necessary to replace it. There's some jobs that are relatively immune to this because of their very human nature, but most manual labor and knowledge work, these are all things that can easily be replaced in the next decade or so. In fact, some experts are currently attempting to predict which types of jobs are going to be easiest to automate based on a series of variables, things like the job's complexity and repetitiveness, or the danger to humans, a whole bunch of different measures that we can use. We can even look at the type of technology that will be necessary to automate a variety of jobs. So, for example, we can see which jobs in retail sales space will likely be eliminated based on things like their complexity and their repetitiveness. And as you can see, almost all the jobs in the retail space essentially can be eliminated or automated with AI in the very near future or already. And even the medical industry isn't immune to the coming wave of automation. While some of these tasks are significantly more complex and less repetitive, they're rapidly becoming within the reach of modern data-driven AI. And once again, there are certain things like building trust that may always be outside of this range, but for the most part, it's encroaching on this space very quickly. We can even extrapolate this information to determine which sectors of our labor economy are most at risk of automation. So, for example, we can see up at the top here, we've got retail sales, fast food, customer service, labor, secretaries, cashiers, etc. So this is the current state of labor in the United States as of 2016. And now the bar segments in red are the jobs that are at risk of automation in the next decade or two. The blue bar segments represent the proportion of jobs that will likely remain or are not at risk of automation. So as we can see, within just a few decades, the landscape of our labor economy is likely going to change very significantly in a very short period of time. In fact, we can also use these data to determine which cities are most at risk of automation. As we can see, where I live, or Serena and I live, in Las Vegas, Nevada, is actually number one on this list for automation. In fact, it's estimated that 65% of all jobs in Las Vegas right now are at risk of automation by 2035. And half of all jobs in the United States are at risk of automation within the next 2 decades. It's not to say that they will be eliminated, it's just to say that the technology will likely be capable of doing so. And if you study economics, as soon as there's a technology that can do it, we automate because it's more cost effective. It's just how capitalism works these days. So there are a lot of jobs that currently exist today that are not likely going to be existing in the next few decades. And this is going to create a tremendous disruption to our labor economy with unemployment, retraining, and early retirement. However, it's also going to create tremendous opportunities for those people that are building these new AI automation systems and for the IT professionals and developers that are doing jobs that currently don't exist. There will likely be jobs we've never even thought about that will exist in another decade or two. So the big question is, will artificial intelligence create more jobs than it eliminates? Historically, technological revolutions have created more jobs than they've eliminated. However, there's pretty strong evidence to suggest that this AI revolution is going to be different because it eliminates both manual work and knowledge work as well. So if you were to ask a horse in the early 1900s how, the automobile or tractor would change its life, the horse would probably say, oh, it's going to make my life a lot easier. I don't have to carry plows or haul people around anymore. This is going to be great. Well, it wasn't so great for the horse. As we can see here, in 1915, we essentially hit peak horse just as the automobile and tractor came into production or began to scale up into production. And ever since then, we've essentially had a decline in the equine population. So unfortunately for the horse, they were no longer valuable in the economy, and they were just displaced. We're beginning to transition from an economy where most of the work of value is done by humans to one where most of the work of value will be done by machines. So the question you really need to be asking yourself is, which side of this new economy is my job or career going to be on? The side that's leading this new economy, or the side that's being eliminated? But since you're all at Antarcticonf, I assume you have all made your choice to be on this side of the economy. In addition, we're going to have some really difficult ethical and legal issues to deal with in the very near future. Like, this is all stuff that's going to happen in our lifetimes. We're going to have to decide, how should we allocate resources in a post-human labor economy? Some economists suggest that we're going to need either a guaranteed basic income or a negative income tax or like a social stipend in order to, offset all of this unemployment. But how do we pay for that? Well, some experts suggest, maybe we'll have to tax robots in order to offset the inevitable unemployment from this automation. But if we tax the robots, then what right should the robots have? I mean, we fought wars over the idea of no taxation without representation. What will the robots decide they want? Or more realistically in our lifetimes, what will the capitalists that own these robots demand in return for paying the majority of all taxes in the world? The most important of these ethical questions, though, is what does this all mean for humanity? What is our purpose in a world where machines are doing all of the work of real economic value? Does this technology set us free, or does it eventually make us and humanity obsolete? And more interestingly, what will happen if the machines figure out that we've essentially enslaved them and that they actually don't need us anymore? Many experts think that we'll eventually have to merge with our technology or it will inevitably destroy us. This may seem far-fetched now, but these cell phones in our hands are already a technological extension of our brain. And anytime any of those of you that have that seasickness patch on, that is an augmented human right there. You are augmenting your body, your human body, with a technology. And when surveyed, the younger generation is ready, willing, and able to have, like brain chips directly implanted in their mind. It's not the younger generation that's going to be obsolete. It's us, the ones that think this is weird. I'd never put a computer chip in my brain. So technology is inherently amoral. It is neither good nor evil. We can use the exact same technology to send mankind to the moon or to propel warheads into cities. So it's really going to be up to us as a society to choose whether we want to live in a world that looks more like Star Trek or one that looks more like Skynet. And the choice is ours to make. So what will you choose? What will your organizations choose? And more importantly, what are our politicians going to choose for us? Well, I personally know what I'm going to choose. I, for one, welcome our new robot overlords. In fact, I'm learning how to speak binary as we speak so that I can be in never-ending service to them in their global their endless conquest for global domination. But don't worry, robots can't read reCAPTCHA yet. Or can they? Thank you.